Welcome once again to Anything Maths. This video is going to look at the difference between displacement and distance covered or distance traveled. It's part of a series of videos that will deal with motion under constant acceleration. Like the video and also subscribe to the channel. What is the difference between displacement and distance covered? The basic difference is this. Displacement is a vector quantity. A vector quantity. And distance is a scalar quantity. Vector quantity implies one or A, it has a magnitude, and B, a direction as well. Scalar quantity implies only magnitude. We're going to look at some diagrams that will help you to spot the subtle difference between displacement and distance travel or distance covered, because that is so fundamental in solving questions under constant acceleration. Now we have a very nice diagram that will help us to spot the subtle differences. First of all, we're going to label the diagram. So this is the initial point. Let's give it O. Then from O, P, Q, and T. So that it's moving from O to P, then from P to Q, and then from Q to T. The distance between O, P is x1, the distance PQ is x2, and distance QT is s3. Distance OQ is y1 and OT is y2. We're going to represent displacement by x. So we can say x is equal to displacement. Okay, so that is just for this video. In your question, maybe they will use different letters. And we're going to use D for distance covered or distance traveled. The question though is, you're moving from O to P. So when you are at P, what is the displacement and what is the distance? So at P, the displacement S will be equal to OP as the distance, which is also giving us x1. The distance traveled, which is D, will be the same. So at P, the distance traveled and the displacement, they are no different, they are the same. So this tells us that at some point we can have distance being equal to displacement, but not all the time. What about when you move from P to Q? Let's have a look. At Q, the displacement is OQ, which is y1, but the distance is OP plus PQ, which then gives you x1 plus x2. So it's quite clear that at this point, the distance covered or traveled is totally different from the displacement at Q. Let's look at when you are at T. At T, what happens? At T, displacement becomes OT, which gives you y2, and the distance you'll be thinking is OP plus PQ plus QT. And if you do the substitution, get x1 plus x2 plus x3. We can see a very great difference between the two at this point. We're going to look at another diagram that will really help us, because we're going to sign some negative and positive with reference to where we're coming from. That is really important. It's just a sign convention. Don't get so worried about that. Now, this diagram actually is nice, isn't it? So this is something like a block, and we have the ground. This is the ground, and someone is here, and you throws a ball, it goes through and land at the point A. Okay, so we're going to look at the flight in terms of a vertical motion. So vertical motion, that's what we're going to look at, vertical motion. So when you throw, it goes up and fall down to point A. So the question is, what will be the displacement at point A in terms of the vertical motion? So we have the vertical motion. At A, what will be the displacement? The displacement at A will be negative h0. Maybe you will be saying, why is negative h0? Now, because we will stand at point O, anything above O is viewed as positive, and anything below O is viewed as negative. So we can see that when it lands at point A, it's moved h0, but it's going to the south, so it's going to be a negative. Okay, so the displacement is negative h0. It's so important when you start solving questions, and you have to be careful. It depends on what you are looking at. Okay, so when you solve questions, it becomes much more apparent to you. Now, what is the distance traveled? The total distance traveled is going to be 2h1 plus h0, because it's go up h1, come down h1, then travel further h0. So it's 2h1 plus h0. 0. Okay, so you can see the difference between these two quantities. The displacement is quite different from the distance traveled, and this has to do with vertical motion. I'm stressing it because I know most of the students get confused. We are dealing with vertical. We are looking at the flight of the ball in a vertical motion. So we are looking at in the vertical motion like this. Okay. And we can also look at the horizontal motion, but we're not really much concerned at this point in time. Although the movement is moving at that like a parabola, we just concern ourselves with the vertical motion. So when you're looking at it from that perspective, the displacement becomes negative h0 and the distance travel becomes 2h1 plus h0 or h0. Okay. This brings an end to this video. Like the video and do subscribe